All right, this is Algebra 2, spring test number 1, study guide for test number 1. We factor in the expression x squared plus 10x plus 16. We have a trinomial. We're making two binomials. So you need to set two sets of parentheses. X times x, when you FOIL, it's the only way to get x squared. We want to look at our C value 16 and factor it out in order to get 10. 1 and 16, 1 times 16, 2 times 8, and 4 times 4. And 4 and 4. The only pair of those numbers that's going to give you the B value 10 is 2 and 8. So we need to use the numbers 2 and 8. The sign in front of the C is positive. That means they're both going to be the same, either plus plus or minus minus. Since they're both the same, this one tells you they're both. So since they're both the same, that one tells you they're both positive. So when you factor it out, it's x plus 2, x plus 8. Or x plus 2 times x plus 8. We're solving this equation and we're checking our solution. The fact that it says m instead of x or y, don't let that bother you. It's just a variable. You still want to undo in reverse order of your order of operations. So we want to undo this minus 1 by adding 1 to both sides. So we have 11 equals the square root of m. Don't think of that as slope and all that. Just think of it as a variable. Get rid of the square root of something or cancel it out by squaring it. You square that side, square this side. 11 squared would be 11 times 11, which is 121, equals these will cancel out m. Then it says check your solution and see if it gives you a true statement. 10 equals the square root of 121 minus 1. Square root of 121 is 11 minus 1. That does equal 10, so it checks out. Number 3 says the square root of a minus 7 equals 10. Unlike number 2, where you had to get the radical by itself, number 3 is already by itself. So square that to cancel it out. Do the same here. A minus 7 equals 10 squared is 100. Get rid of minus 7 by adding it on both sides. A equals 107. Number 4, you have the square root on both sides. We hadn't seen one like this, but it's actually, I put it up there to show you that it's actually easier than the other ones we've been dealing with. In order to get rid of the radical, you take the square root. I'm sorry, it's the radical, you square it. So if you do that to that side, do it to this side, and you're going to cancel them both out at the same time is what's going to happen. And you're going to be left with 5x minus 10 equals, it'll cancel here as well, x minus 2. And then it just becomes an equation with variables on both sides. Bring your smaller 1x over to the 5x side by subtracting it. If it's subtracted there, take it away from there, and you'll get 4x minus 10 equals, they still have a negative 2 on that side. Move everything else to the other side. Minus 10, cancel it out by adding it and do it here to balance it. 4x equals positive 8. Then get x by itself to cancel out multiplication of 4 by dividing it and do it here. X equals 2. And again, when it says to check your answer, plug it back in. 5 times 2 is 10. Minus 10 is the square root of 0. The square root of 0 equals, plug in 2. 2 minus 2 is 0, so the square root of 0 equals the square root of 0. We didn't check this one. 107 minus 7 is the square root of 100, and the square root of 100 is 10. So just plugging them back in to check and make sure, because it says that in instructions. It says solve this equation, identify any extraneous solutions. So, okay, this is what we've been working on this last few days. Get rid of square root by squaring it. Square it here as well. So you have x squared equals 3x plus 54. So we actually have a little less work to do here. You want x squared to be positive. You don't want to make a negative x squared. It makes the problem much harder. So even though there's only one thing on the left and two on the right, let's bring the two things from the right over to the left. Subtract 3x, and you'll have x squared minus 3x, and subtract 54, and you'll have minus 54, and all of that will be equal to 0. Sometimes there's more than one way to do it. Okay, so we have a trinomial. We got to separate it. We have to make it into two binomials, x times x. Your factors of 54 that are going to get you to 3 or 6 and 9, just to where we can speed up a little bit and make it in time. 6 and 9. This one tells you that they're going to be different signs. This one tells you since they're different, the larger value 9 is going to be negative. This one's positive. So both of those are equal to 0. So x plus 6 equals 0, or x minus 9 equals 0. So that gives you x equals negative 6 when you subtract it on both sides, and x equals positive 9. Check both of those and see if they work. So you have negative 6 equals the square root. 3 times negative 6 is negative 18. And when you subtract 18 from 54, you get the square root of 32. The square root of 36. 36, everybody. So you have negative 6 equals, and this looks like one we looked at on the bell word, the square root of 36, which is 6 equals negative 6. That one doesn't work. That's just like the one on the bell word. Do the same thing with your 9 value. 9 equals 3 times 9 is going to be 27 plus 54. 27 plus 54 is the square root of 81. 9 is equal to 9. So you have an extraneous solution. It says identify any extraneous solutions. It would be negative 6 in this case. So when you have the answer, you're going to pick the version that says x equals 9 and negative 6 is extraneous. You're going to one. It's going to be just like that. Okay, vertex form. Remember, vertex form is y equals a times x minus h squared plus k. Remember, you don't have to remember the difference between the h and the k. Just remember it's the opposite of x here, and it's the same as k there. Okay, so we have to figure out what they all are in order to get this. After looking at number 6, I actually decided we're going to take this one off of the test. I don't like how a's value is not 1. Remember, it created something where we had to multiply both sides by the value, and it caused a lot of problems the last time we did it. So let's go ahead and take 6 off. Let's move to number 7. 7 says solve by finding square roots. 2x squared 2x squared equals 30. You have to undo multiplying before you undo squaring, so divide it by 2 on both sides, and you have x squared equals 15. And then in order to undo squaring something, take the square root of it. X, these will cancel out, equals the square root of 15, and that can't be simplified any farther than that without estimating as a decimal, so that's good enough, square root of 15. Number 18. This, we're writing it in the form a plus bi, the square root of negative 4 plus 7. In order to take that negative out from under that radical, we're going to create an imaginary number, the square root of 4 times I plus 7. The square root of 4 is 2 times I plus 7. And then to make it say standard form a plus bi, just reverse the order, 7 plus 2i. Number 9, we find the value of c, ax squared. It's ax squared plus bx plus c. So we're looking for c. In order to find c, you take b divided by 2 and square it. So the b value in this case is 16 divided by 2 squared means 8 squared, which is 64. 10 says solve this by completing the square. We want ax squared plus bx plus c, which we have here, plus 57, but we want it to be a perfect square to where we can create binomials. 57 does not create a perfect trinomial for us, so we need to move that to the other side of the equal sign. Get rid of plus 57 by subtracting it. So you have x squared plus 16x plus c equals negative 57. So just like on the last problem, we have to find c. So take your b value, which again is 16, divided by 2 is 8 again. Multiplied or squared is plus 64. But if you add 64 to one side of the problem, you have to add it to the other side. So now you have a perfect trinomial here. Remember, you want to take the square root of the first one, which is x, and the square root of the second one, which is 8. The sign in front of the b tells you to put plus between them. So x plus 8 squared equals negative 57 plus 64 Negative 57 plus 64 is going to be positive 7. So in order to get rid of squaring this whole left side, you want to take the square root of it. That'll cancel it out and leave you with x plus 8. If you take the square root of the left, you got to do the same thing to the right, the square root of 7. So the only thing we have left to do to complete this square is to get x by itself by getting rid of plus 8 and subtracting it on both sides. X equals negative 8 plus the square root of 7. Number 11, rewriting it in vertex form. This is a much better one than number 6 was to rewrite in vertex form. We still have to create a perfect trinomial by getting ourselves another c value. So subtract 30 to start. That c value doesn't work. Subtract it from the left side. So what we have now is y minus 30 on the left equals x squared minus 12x, ax squared plus bx, and then we have to find ourselves another c value. So again, take the value of b, negative 12, divided by 2 and get negative 6, and square that and get positive 36. And again, if you add something to one side, add it to the other side. 36 minus 30 is going to be y plus 6. Now we have a perfect trinomial on the left. Perfect trinomial. You take the square root of the first one and get x. The square root of the last one and get 6. And this sign, remember the one in front of b, tells you to put what in between them, minus. So now we have one more step to create vertex form. We want it to say y all by itself. So get plus 6 away from the left side. Subtract it on the right side. And y equals x minus 6 squared minus 6. We're rewriting in standard form. Standard form is just ax squared plus bx plus c. Oh, we're just foiling is all we're doing. So your first two terms that you're multiplying, x times x, is x squared. Your outside terms are x times 4, positive 4x. Your inside terms are 2 times x, which is positive 2x. And then your last two terms are 2 times 4, which is plus 8. The only thing you have to do to create it at this point is put your like terms, 4x and 2x together and get 6x. It's positive, so x squared plus 6x plus 8. And that says ax squared plus bx plus c. Okay, this says to divide negative 2x cubed minus 2x squared plus 4x plus 2 by x minus 3. Easiest way to divide all of this nonsense is to use synthetic division. Remember, for synthetic division, use the opposite number, that negative 3 right there. It's positive 3. It's going to look familiar when I write them down. You want the coefficients of all the other numbers. Make sure that you don't skip any degrees, though. X to the third, x to the second, x to the first, then no good. They don't skip any degrees. So negative 2, then negative 3, then positive 4, then positive 2. You bring the first one down, you don't mess with it. You call it negative 2. Then you multiply it by the 3. So negative 2 times 3 is negative 6. Then you combine negative 3 and negative 6 and get negative 9. Multiply it by 3 and get negative 27. Combine 4 and negative 27 and get negative 23. Then multiply negative 23 times 3 and get negative 69. Combine 2 and negative 69, you get negative 67. Okay? So that's going to create our answer right there. Remember, it's always 1 degree less than the first one. So that's x to the third power, so you have negative 2x squared instead of to the third power. Minus 9, you just count the degrees down, x to the first power. Minus 23, there are no more x's to include. So what this is here is our remainder. Remember, with your remainder, you simply put minus 67 over your original denominator, which is x minus 3. And all this nonsense here is the correct answer. The next division problem, number 14, actually sets up a little bit easier for us, but we'll use the same steps. You still want the opposite number of this one, so you want negative 2 as what you're going to divide by. All of your degrees are represented, 4, 3, 2, 1, Constant, good. So we want all of the coefficients. It's 1x, so 1, negative 2x cubed, so negative 2, negative 19x squared, and then positive 16. Bring that first one down is 1. Multiply it times negative 2, and you get negative 2. Combine those, and you get negative 4. Multiply that times negative 2, and you get positive 8. Combine those, and you get negative 11. And multiply 2 times negative 11. I actually left one off here. That's what I had to correct in that right there. Make sure you don't leave anyone off like I just did. It's negative 19x squared, then negative 14x, and then positive 16. Now it's going to turn out right. So when you multiply negative 11 times negative 2, you get positive 22. Negative 14 combined with positive 22 is going to give you 8. And then 8 times negative 2 is negative 16. That's going to give us a remainder of 0. Again, it always goes by 1 degree less than the first one. So this 1 goes x to the third minus 4. You just count down your degrees. X squared minus 11, x to the first power, positive or plus 8 with no x, and there's no remainder. And we'll pick up the second part on number 15 after this on part 2.